Okay, this lesson will be doing vector addition using another method. So we'll be adding vectors using this vector resolution method. So in order for you to understand this method, you need to have some prior knowledge, which include basic trigonometry operation, which mean sine, cosine, and tangent. And you also need to know how to apply Pythagoras theorems. So vector resolution, it stems from, since we know that a vector can be made out of other vector arrows, so we can actually do the opposite and try to break down any given vector arrows into its component. What I meant was that if you have this red force arrow, you need to resolve the vectors. So this is known as resolution of vectors, and usually we break it down into two arrows, that one is parallel to the horizontal and the other parallel to the vertical axis. So this is what I meant, and of course these two will form a right angle 90 degrees, and this entire thing will be a right angle triangle. So for a right angle triangle, we can apply your trigonometry value to try to find the vertical and the horizontal part. So just a revision, sine, cosine, and tangent. Usually the angle that we use is this. So this will be your hypotenuse, this is your opposite to your angle, and this is the side that's adjacent to the angle. So why do we use this method? It's because it may be too difficult to draw a scale diagram with lots of vectors, especially if it's 4 and above. 3 is still manageable, but 4 and above, it can lead to a very messy diagram, and it is actually difficult to keep track of which vector to shift using the tip to tail method. So vector resolution method is easier to compute when we deal with a lot of vectors. This is the main advantage. It's because the method actually breaks down all the different vectors into its respective horizontal and vertical direction, irregardless of number of vectors. So you just only need to add up and also subtract away all the vectors in the horizontal direction, and likewise you also just add up or subtract away all the vertical direction, all the vectors that's in the vertical direction. And we use the Pythagoras method to combine the resultant horizontal and vertical results. Even with more vectors, the steps required are exactly the same. You just only need to break down the additional vectors into its horizontal and vertical component, and you just add and subtract accordingly. So we use a PHET simulation to help you to understand the idea. Okay, let's look at this simulation. You have 4 vectors or 4 forces acting in all directions. So if you need to add them up, you can actually shift them to here, okay, here, and then here. So and then you can show the results. Okay, so this would be the resultant vector. Okay, but you find that actually theoretically is easy, but practically, in order for you to draw this is actually not that easy. Okay, in fact, it could be quite tedious. Okay, it can be quite tedious. So let's just put them back. So what we actually do is that instead of drawing a scale diagram, we use the vector resolution. Okay, what do you mean by vector resolution? Okay, we'll see. Okay, so each of the forces or each of vector, you just need to break down into its horizontal and vertical component. Okay, horizontal and vertical, horizontal and vertical, horizontal and vertical. So that means that these red arrows will be replaced by the pink arrows. And since the horizontal components are just so as horizontal, okay, that means that it's either going to a left or right. So you just need to add these 4 arrows together up and try to find out the resultant. Okay, it's just only a matter of addition and subtraction. Similarly, for the horizontal, you just only need to add the vertical arrows, 2 up and 2 down. So you just only need to find out the resultant, and subsequently you get 2 vectors, one horizontal, one vertical, and you use Pythagoras to do it. Okay, so we'll use the actual example to help you to understand. So using this component method or vector resolution method, the example, so we have three forces or 3 vectors, A, B, and C. Okay, we use forces as an example. So you have 50 degrees, okay, to the horizontal, this one is 60 degrees and this is 25 degrees. Okay, the angle that we use generally we will align it to the horizontal for easy reference. Anyway, the diagram is not to scale. It actually doesn't matter because we are not drawing a scale diagram. And another point to take note is that for horizontal axis we generally take right as positive and left as negative, and for vertical axis we take up as positive and down as negative. Okay, so right now we need to resolve A into its vertical and horizontal component as shown in the idea in the simulation. So this is A, which is 5 Newton, and this is 50 degrees. This would be your, since this is the right angle, this would be the hypotenuse, this is the opposing, and this is the adjacent. Okay, we denote this as AX, which is the x aligned with the x-axis, and this is actually the AY. Let's say if you want to find out what is AY, so this would be the AY is multiplied by this. Okay, and you can find it is actually based on 5, this is 3.83. So this one comes from that sine angle theta equals to the opposite over hypotenuse. If you want to find out what is the opposite, you just multiply your hypotenuse multiplied by the sine theta. So A is the hypotenuse and angle 50 is the angle theta. So similarly, if you want to find AX, is just AX equals to A cos 50. Okay, again it comes from the idea that cos theta is equals to the adjacent divided by hypotenuse. Okay, so remember that it is 3.21. Okay, and this way right, and 3.83 up. So similarly we just ignore A and we do for B. So B in this case would be just, this is 4, this is angle 60. So do this, and for this is BX, BY is going down. But I want to point to take note is that since Bx is towards the left, so instead of 2 is actually denoted as negative 2 Newton. And since By is towards down, okay, and then in this case instead of 3.46 is actually negative 3.46. So we do the same thing for C. Okay, so Cy is 1.69 up and Cx is 3.63 left. So again, since Cx in this case is towards left, it is a negative value, and then this is Cx, okay, it's actually 1.69 up. If we do a consolidation, this is what's going to happen. So we replace A by these two vectors, B by these two orange vectors, and C by these two green vectors. That means that if we want to find out what is the net horizontal force, we just only need to add up those that's up or down. So we remove the horizontal, we just add all this up together. Similarly, if you want to find what is the net horizontal, you just remove all those the vertical forces and you just add up all these three. So summing the horizontal component of A, B and C, and again we take right as the positive direction. Okay, so you just add AX, BX, CX and this other part, and you find that the end result is negative 2.42. So what it means is that if you add up all the horizontal forces, it will be actually 2.42 Newton towards the left. So we do the same thing for the vertical component, but this time around we take positive up as the positive direction. Okay, so again you write AY, BY and CY. Okay, you find that the end result is 2.06, so it means that it is vertical upwards 2.06. So summary, okay, the resultant is 2.06 up and 2.42 left. So this is the picture. Okay, but this is not the end of story because we need to combine these two. And how do we combine? And since this is a right angle triangle, and using the tip to tail method, this is start, this is end, you find that you just draw an arrow from here and to here. You find that this would be the end result of the force by adding this A, B, and C. So by Pythagoras theorem, since it's a right angle triangle, you can use your Pythagoras theorem. You just square them, okay, and then you root it. So you find that end result is 3.18 Newton. Okay, and then of course for force, not only the magnitude is important, we also need to understand what is the angle. So right now we use the angle to find this angle theta, and we know that tangent theta is equals to the opposite over adjacent. So in this case, opposite is your ry, adjacent is your rx. So you just only need to transfer over, and that's why it is ry over rx, and the angle will be 40.4 degrees. Okay, so this is actually how you find out what is the resultant force of using vector resolution. Okay, that's the end of today's lesson. Okay.